Welcome to a presentation on the Planetary Boundaries. This is the Sustainability Channel, and I'm your host, Thomas Stanley. So, I will present the concept known as the planetary boundaries, which is used to define the limitations of how much human activity can affect the Earth system within the boundaries of sustainability. The ecosystems might no longer be able to self-regulate after these points are reached. This would indicate that the Earth system would leave the stable Holocene epoch, during which human society flourished. The framework is based on scientific data showing that human activity has become the primary cause of environmental change on a worldwide scale, particularly in industrialized cultures that have undergone industrialization since the Industrial Revolution. The concept states that crossing one or more planetary limits has a danger of causing non-linear, rapid environmental change within continental scale to planetary scale systems, which can be detrimental or even disastrous. In 2009, a team of Earth system and environmental scientists led by Will Steffen of the Australian National University and Johan Rockström of the Stockholm Resilience Centre created this framework. Additionally, they worked with 26 eminent scholars. The interdependence of these boundaries underscores the necessity of managing the planet's resources and ecosystems in an integrated and sustainable manner, as exceeding one limit might have an impact on others. Keeping the environment stable and favorable for people and other living beings on the Earth is the aim. Although the idea has gained a lot of traction in academia and policy circles, scientists have also criticized it, arguing that it oversimplifies a complicated system, that it could undermine political will, and that most of the thresholds it presents have already been crossed. It is also criticized for being reductionist, taking a technological approach, and not taking social factors into account. The many boundaries have been defined and analyzed since its inception in 2009. The third significant update to the framework, published in Science Advances in 2023, evaluated all boundaries. After that, 6 boundaries were found to be crossed, and pressure is mounting on every boundary process with the exception of ozone depletion. Now I will address each boundary one at a time, beginning with climate change. Climate change is a planetary boundary with decisive implications for ecosystems and human well-being. Important aspects include emissions of greenhouse gases. Climate change is driven by increased concentrations of greenhouse gases, carbon dioxide, methane, and gases from human activities, such as the combustion of fossil fuels and industrial production. Global average temperature. A limit for the average temperature rise is set within planetary boundaries in order to avoid dangerous and irreversible consequences. Global sea level. The warming leads to melting of glaciers and polar ices, threatening coastal communities and increasing the risk of flooding and erosion. Extreme weather events. Climate change increases the probability and intensity of extreme weather events with serious consequences for ecosystems and societies. Changes in rainfall patterns. Climate change affects rainfall patterns, which can lead to increased droughts or floods and affect food production. Loss of ice sheets and glaciers. Warming causes loss of ice sheets and glaciers, not only affecting sea levels but also reducing the availability of fresh water. Sea acidification. Carbon dioxide emissions cause ocean acidification, affecting marine ecosystems and organisms with limestone shells such as corals. Climate change feedback. Certain changes can trigger climate change feedbacks that reinforces climate change, such as melting permafrost that releases methane. Adaptation and reduction of vulnerability. Managing climate change requires adaptation and reduction of vulnerability through the transition to renewable energy sources and sustainable agricultural practices. International cooperation. As climate change is global, international cooperation is required, as reflected in the Paris Agreement, to limit the increase in temperature. Novel entities within planetary boundaries include the introduction of new chemical compounds and technologies into the environment. Important aspects are synthetic chemicals, includes industrial chemicals, pesticides, pharmaceuticals, and other man-made substances. Pollutants. Human activities introduce new pollutants, including heavy metals and synthetic organic compounds. Nanomaterials, materials on a nanometer scale with potential effects on the environment and living organisms. Genetically modified organisms, GMOs, introduction of genetically modified organisms with altered hereditary mass for increased durability or yield. Technological innovations, new technologies such as artificial intelligence with complex effects on society and the environment. Combination effects, interactions between different substances and technologies can have unexpected consequences. Uncertainty and the precautionary principle. The precautionary principle is applied because of scientific uncertainty about the consequences of novel entities. Monitoring and regulation. Effective monitoring and regulation is required to minimize potential risks. In conclusion, novel entities within planetary boundaries is an important aspect where caution and regulation are needed to minimize impact on the planet's stability and sustainability. Stratospheric ozone depletion within planetary boundaries refers to the breakdown of ozone molecules in the stratosphere, especially in the ozone layer. Important aspects include ozone layer. Stratospheric ozone depletion is linked to changes in the ozone layer, which absorbs UV radiation and protects life on Earth. Chlorofluorocarbons and halons. Human-made chemicals used in refrigeration and freezing appliances, aerosols, and fire extinguishing equipment are the main causes of ozone degradation. Catalytic degradation processes. Released chlorine atoms catalyze the degradation of ozone molecules. Ozone holes. The formation of ozone holes, especially over Antarctica, is a clear effect of stratospheric ozone degradation. Biological consequences. Increased exposure to UV radiation affects plants, animals, and humans, with risk of skin cancer and damage to marine ecosystems. International agreements. The Montreal Protocol was adopted to reduce the production of ozone-depleting substances, demonstrating effective international cooperation. Recovery of the ozone layer. Thanks to measures under Montreal Protocol, the ozone layer is beginning to show signs of recovery. Continuing monitoring. Continued monitoring and compliance with regulations is crucial to ensuring the stability of the ozone layer. In conclusion, stratospheric ozone degradation is an important planetary boundary where international efforts have been successful in mitigating the threat to the ozone layer and its protective function for life on Earth. Atmospheric aerosol loading within planetary boundaries refers to the particle and liquid drop content in the atmosphere, which has a significant impact on both the climate and air quality. The key aspects are sources of aerosols, natural and human sources including forest fires, volcanic eruptions, industrial combustion, and vehicle emissions affect aerosol levels. Particle size and composition. Various particle sizes and compositions affect the behavior of aerosols in the atmosphere and their impact on climate and air quality. Climate impact. Aerosols act as cloud-forming cores, affecting sunlight reflection and absorption, directly affecting global temperature and cloud life. Air quality impact. Contributes to the formation of particle material and thus affects air quality, especially with small particles that can affect respiratory health. Health effects. Some aerosols contain hazardous substances, which can cause respiratory problems and affect people with existing diseases. Regional differences. Aerosol levels vary depending on geographical areas, with higher concentrations in cities with heavy industry and traffic. Black carbon. The aerosol black carbon from incomplete combustion absorbs sunlight and contributes to atmospheric warming. Reduction measures. Reducing aerosol loading requires measures such as reducing the combustion of fossil fuels and the use of cleaner technologies in industries and vehicles. Global collaboration. As aerosols are transported over long distances, global efforts are needed to address their impact on both the climate and air quality. So understanding and managing atmospheric aerosol load is crucial to preserving a sustainable and healthy atmosphere, which requires scientific research, technological innovations, and international efforts. Sea acidification within planetary boundaries refers to increased acidity in seawater, mainly caused by increased absorption of CO2 from the atmosphere. Here are the key aspects of ocean acidification. Carbon capture and formation of carbonic acid. Seas absorb carbon dioxide, forming carbonic acid, thereby lowering the pH value, indicating increased acidity. Decreasing pH value. Since the industrial era, the pH value of the oceans has decreased by about 30%, indicating a more acidic environment. Calcium shell-forming organisms. Affects organisms with calcareous shells, including corals, clams, and plankton, by making it more difficult to form and maintain their shells and skeletons. Marine ecosystems. Affects ecosystems by interfering with organisms at different trophic levels, which can have consequences for fish stocks and thus affect human food supply and economies. Threat to coral reefs. Coral reefs become vulnerable as more acidic water makes it difficult for corals to build shells and increases the vulnerability of coral bleaching. Marine biodiversity threatens marine biodiversity by affecting organisms of varying sizes, which can create imbalances in ecosystems and affect entire food chains. Economic implications. Decreased survival of calcium shell-forming organisms may affect industries that are dependent on these organisms, including seafood harvest and certain sectors of the fisheries industry. Reduced CO2 absorption. This can create a positive feedback effect where the reduced ability of the oceans to absorb carbon dioxide exacerbates global climate change. So, to mitigate the impact of marine acidification, measures such as reducing carbon dioxide emissions and protecting marine ecosystems are needed. International cooperation and sustainable management strategies are crucial to managing this planetary boundary and minimizing its negative impact on the seas and its biodiversity. Biogeochemical flows within planetary boundaries refer to natural cycles and flows of chemical substances and nutrients through Earth ecosystems. These flows include carbon, nitrogen, phosphorus, and other biogeochemical elements. Here are the key aspects of biogeochemical flows. Carbon cycle regulates the flow of carbon between the atmosphere, land, and ocean. Human influences such as deforestation and fossil fuels have increased carbon dioxide levels and affected the climate. Nitrogen cycle. Human activities, including the production of artificial fertilizers and the combustion of fossil fuels, have increased nitrogen levels in ecosystems, which can lead to over-fertilization and affect air quality. Phosphorus cycle. Human drainage from agriculture and the use of phosphorus in fertilizer increases the supply of phosphates to waterways and causes eutrophication. Mineral extraction impact. Human extraction of minerals affects biogeochemical flows through the release and redistribution of these substances. Land use impact. Changes in land use, including deforestation and urbanization, affect biogeochemical flows by affecting the regulatory capacity of the soil. Climate change and biogeochemical flows. Climate change affects flows by affecting temperatures, precipitation, and other variables. Protection of biogeochemical flows. The preservation of natural ecosystems and their flows is crucial to the stability of the planet. Sustainable agriculture and land management. Responsible use of fertilizer and pesticides as well as sustainable land use minimizes the impact. Global commitments. International cooperation like the Paris Agreement is crucial to reducing human impact and maintaining the sustainability of the planet. In conclusion, understanding and sustainable management of biogeochemical flows is crucial to preserving the ecological balance of the planet and avoiding transcending planetary boundaries with serious consequences for humans and the environment. Freshwater change within planetary boundaries is about changes in the availability and use of fresh water on Earth. Important aspects include water consumption and use. Human use of fresh water affects the planet's resources, especially in agriculture, industry, and households. Water pollutants. Pollution from industry and agriculture affects water quality and the health of ecosystems and people. Overdrafting of groundwater. Dependence on groundwater for irrigation and drinking water increases the risk of lower groundwater levels and soil deposits. River regime and water flows. Changes in river regimes and water flows affect the ecosystems of rivers and streams. Climate change and rainfall patterns. Changes in rainfall patterns affect the availability of fresh water, especially in areas that depend on snow and ice melting. Water scarcity and water stress. Some areas are experiencing water shortages and water stress due to rapid population growth, poor water management, and climate impacts. Protection of aquatic ecosystems. The preservation of aquatic ecosystems, such as wetlands, lakes, and rivers, is crucial for freshwater change within sustainable limits. International water cooperation. Since many water streams extend across national borders, international cooperation is required to tackle common water challenges. Sustainable water stewardship. Sustainable water stewardship balances human water needs with the preservation of ecosystems and ensures sustainable access for present and future generations. In conclusion, freshwater change within planetary boundaries means a holistic view of water resources in order to maintain a balanced and sustainable management of fresh water globally. Changes in land use within planetary boundaries refer to major changes in the way humans use and manage the surface of Earth. Here are the key aspects of land use change. Deforestation. Large-scale deforestation for agriculture, settlements, or industry affects biodiversity and contributes to carbon dioxide emissions. Urbanization. Increased urbanization transforms natural landscapes into cities and thus changes local climate conditions and ecosystem services. Agriculture expansion. Expansion of agriculture to meet food needs can transform natural ecosystems and affect soil productivity. Monoculture and intensive cultivation. Increased use of monoculture and intensive cultivation affects biodiversity, nutrient content in the soil, and can lead to overuse of water and chemicals. Changes in water use. Land use transformation affects water flows and water use, including the creation of ponds and canals. Changes in soil coverage. Land cover shifts affect the soil's ability to function as a carbon sink and support biodiversity. Climate change and land use. Changes in land use affect climate change by affecting greenhouse gas emissions and absorptions. Increasing demand for soil resources. Increased demand for natural resources can lead to overexploitation and loss of natural habitats. Protection and sustainable management. Sustainable management of land use requires the protection of natural ecosystems, sustainable agriculture, and responsible urban planning. Changes in land use are closely linked to several planetary boundaries, including biosphere integrity, climate change, and freshwater change. Sustainable management of land use is crucial to safeguarding the ecological balance of the planet and ensuring that human activities do not exceed planetary boundaries. Biosphere integrity within planetary boundaries focuses on the conservation of biodiversity and the structure and functioning of ecosystems. Important aspects include biological diversity, protecting and maintaining biodiversity by preserving species, genetic diversity, and ecosystem diversity strengthens the resilience and adaptability of ecosystems. Threats to ecosystems. Human activities such as deforestation, overexploitation of natural resources, pollution, and climate change pose threats to the integrity of the biosphere and can lead to loss of species and affect the functioning of ecosystems. Protection of endangered species. The conservation of endangered species includes the protection of their habitats, the management of invasive species, and the reduction of human influences that threaten their survival. Protection of natural habitats. Maintaining intact natural habitats such as forests, wetlands, and coral reefs is crucial to the integrity of the biosphere and contributes to the stability of ecosystems. Ecosystem services. Protecting the integrity of the biosphere is necessary to ensure that ecosystem services such as water treatment, pollination, and climate regulation continue to be offered. Protection of coral reefs and marine environments. Particular attention is paid to the protection of sensitive coral reefs and marine habitats in order to preserve global biodiversity and ecosystem services. Sustainable use of natural resources. Sustainable management of natural resources, avoiding overexploitation, and promoting sustainable practices in agriculture, forestry, and fisheries are essential to maintaining the integrity of the biosphere. International cooperation. As threats to the integrity of the biosphere extend across national borders, international cooperation through agreements and initiatives is required to preserve global biodiversity and ecosystems. These are the main sources that have been used for this presentation. Please have a look on the different websites for more information. So, thank you for watching this presentation about the planetary boundaries. Please like this video and subscribe to my channel. That's all for today. Over and out, and live a sustainable life.